and welcome to BioRules video lessons. Today we are going to carry on talking about evolution, and we're going to see two other actually evidence for evolution. One of them is from the structure of the body. So, for example, homologous structures. What's a homologous structure? Homologous structures are structures that have a similar basic structure, a similar blueprint. For example, the arms of vertebrates. Every vertebrate, birds and mammals especially, they are going to have two bones in the forearm, one bone in the top above the elbow. They're going to have several little bones making the hands, and they have usually something around 5 fingers. If all of them have a similar structure, but they have very different way of putting these bones, that's an evidence of structures that have started in a similar place, but they have gone through different directions to try to fill different niches, to try to, being adapted for different functions. So the idea here is that different functions end up being adapted with evolution, with change from a similar ancestor. So humans with 5 fingers, the horses with 1 finger bonded in the middle but surrounding many similar bones in the hand, the cat with 5 fingers, the bat with 5 fingers, the whale with 5 fingers. So all those are evidence of evolution, homologous structure, radiating from one original common ancestor. So that's the idea. Homologous structure, similar structure for different functions. The pentadactyl limb is a classic example of that. Arms with similar bone structure and with 5 fingers. Okay, that implies same ancestor, similar arm structure, evolving, adapting for different functions, different niches, different ways of life. So here is pentadactyl limb. Okay, another idea on the body shape is quite the opposite of irradiation, one ancestor going for different directions. It's convergence, different ancestors, but all of them ending up in similar solutions. So similar body shape, similar overall body shape, but they are similar in the function, they are similar in the way that they look, but they are different internally, different in the basic structure of the body. Okay, so that implies different ancestor evolving to the same function. Good examples of that: dolphins, sharks, ichthyosaurus. All those guys, they have a very similar body shape. They are very hydrodynamic, so they are capable of very powerful swimming inside water. But they have come from different ancestors. Sharks come from fish, they are fish. Ichthyosaurus comes from a land reptile that went back to land, and the dolphin, in this case here, purples, they came from a land mammal. All of them have very similar body shape, but very different internal morphology, showing that they came from different ancestors. Okay, a few other examples: marsupials and placentaries. We have marsupials in Australia. We have placentaries in almost everywhere in the planet, and we have examples of organisms that they have not very different, but quite different origin. One is a marsupial, the other one is a placentary, but they have a similar body shape, occupying similar niche, like the Tasmanian wolf head and the wolves have, like the marsupial mouse and the mouse, like the flying phalanger and the flying squirrel. All those guys, they are different in terms of ancestry. One comes from a marsupial, the other one from a placentary, but they occupy similar niche, so they suffer this convergence. Okay, there are many examples. For example, we have burrowers like the mole, the marsupial mole, the anteater against the wombat or numbat, the mouse, marsupial mouse, lemur, the spotted cuscus, flying squirrel, flying phalanger, bobcat, Tasmanian cat, wolf, Tasmanian wolf. Those are all examples of convergence. Different basic structure going to similar body function, different functions that we have today. Okay? One other evidence for evolution is selective breeding. We humans, a few years ago, we have documentation for something around 10,000 years ago. We started breeding selectively some organisms. For example, wolves. Wolves started living close to us, and we started breeding selectively the ones that we liked most. Oh, look, this is a little bit more docile, so this one we are going to let it breed. This one's a little bit too much angry, so we won't let it breed. And by artificial selecting, we started pushing one species, wolves, into several different directions. And what we have today is, as dog breeds, it's an amazing variation because we have artificially pushed the same species into different directions. The same happens to many other species that we have. For example, here you have pigeons. This happens with chickens, this happens with cats, this happens with fish. We artificially can go selecting, pushing them into one direction. Ultimately, artificial selection does evolution. We artificially have forced organisms to evolve in the direction that we want. Today, it does in a very quick way. By quick, I mean hundreds of years, maybe sometimes for some examples. But even though hundreds of years is very, very, very quick, if you compare to the long-term evolution in the geological time. So we see evolution happening in front of us because we are forcing them to go in one direction. And it's not only for animals. Corn is the longest evolving organism by artificial selection. Original corn was very, very small, a few centimeters wide, a few centimeters long actually, very, very small. And nowadays we have all that variety of corn, and because humans go artificially selecting them for fitting the best of our needs. Another example, mustard. Mustard, the wild mustard, Brassica oleracea, have been artificially selected for different purposes in our diet, making cauliflower, cabbage, Brussels sprout, broccoli, kale, and these are the one that I don't know what it is, the kohlrabi. All these are the same species that have been pushed through artificial selection to fit different purposes on our life. So yes, these are the same species, they are just evolving different directions because of us. And yes, broccoli and cabbage and kale and cauliflower, all the same species. Okay, so by breeding selectively, we are making evolution to happen in the direction that we want. It is one example of evolution happening in a very short period of time. Hundreds of years, 100 years. That's what the time that we are selectively breeding the modern cats. That's a very, very short period of time compared to what long-term evolution usually takes. When evolution is a little bit less focused, a little bit less concentrated, then it takes longer. But we have records of we forcing change into organisms by artificial selection. And that's evolution. That's change. Okay? So, just to give you some example, here we have the wolf. Oh, look how cute. Now the wolf started living with us, and by artificial selecting, we started pushing them into different directions. And we made bloodhounds for hunting. We have poodles that are very smart, but they're also good for companion. We have this that looks like a Shar-Pei or Chow Chow, I don't remember which one is which. And we have this one that looks like a bulldog. Different dogs, all coming from the same ancestor. So this is evolution. It happened just in front of us. Later, we are going to be seeing how this happens. This is for another class. Okay? So now take the time to answer a few questions on this quiz to see if you are nailing this topic. See you in another class.